we have two equations to calculate the standard Gibbs energy of reaction. Equation 1 can be used if we are provided the standard enthalpy of reaction, the standard entropy of reaction, and the temperature. Equation 2 can be used if we are given the standard Gibbs energy of formation of all products, and we are given the standard Gibbs energy of formation of all reactants. And we also need to know the balanced chemical equation, because we need to multiply the corresponding coefficient in the balance equation for the products and for the reactants. Let me use some examples to explain how to use these two equations to calculate the standard Gibbs energy of reaction. Problem number 1. Let's read together. A certain reaction has the standard enthalpy of reaction equal to 23.7 kJ per mole and the standard entropy of reaction equal to 52.4 joule per mole per Kelvin. Assuming that the standard enthalpy of reaction and the standard entropy of reaction do not change with temperature. Number 1. Please calculate the standard Gibbs energy of reaction for the reaction at 298 Kelvin. This is the temperature, and this is what we are looking for. Since we are provided the standard enthalpy of reaction, the standard entropy of reaction, and the temperature, we need to use equation number 1. I copy the equation. This will help me to memorize the equation. Kelvin we cancel. The unit for the first term is kilojoule per mole. The unit for the second term is joule per mole. Therefore, we need to convert to the same unit. I will convert the second one to kilojoule per mole. We plug all numbers into a calculator, we get 8.1 kilojoule per mole. This is the answer for step 1. Let's work on step 2. At what temperature range this reaction is spontaneous, non-spontaneous, or reversible? I copy this equation down again because this will help me to memorize the equation. This is the equation for standard Gibbs energy of reaction. As we have learned in class, if you want the reaction to be reversible, the standard Gibbs energy of reaction should be equal to 0. Therefore, we will get the temperature equal to 452 Kelvin. Then the standard Gibbs energy of reaction equal to 0. And the process will be reversible. But how do we know when the reaction is spontaneous, when it will be non-spontaneous? And if we assume the standard Gibbs energy reaction is Y and the temperature is X, we will get this form. And this is Y. Okay, this is the slope, which is negative, and this is y-intercept, which is positive. If we want to make a plot, it should look like this. This is the temperature, which is also the x-axis, and this is standard Gibbs energy of reaction. Because it has a positive y-intercept and negative slope, we should have a plot like this. And remember, this is 0. So when the temperature is on this side, the standard Gibbs energy of reaction is negative. This side is spontaneous. And this side is non-spontaneous. As a conclusion, when temperature is higher than 452 Kelvin, it is spontaneous. When the temperature is less than 452 Kelvin, it is non-spontaneous. Let's look at another problem. Is the following reaction spontaneous at standard conditions and 298 Kelvin? We are provided a balanced chemical equation and we are given a list of standard Gibbs energy of formation. Apparently, we need to use equation number 2. Let me show you how to do that. The products are carbon dioxide gas and water gas. For carbon dioxide gas, the standard Gibbs energy of formation is negative 394.4 kilojoule per mole. And we have 2 moles of carbon dioxide produced. So we multiply by 2 moles. Water gas is another product. From the table, we find 2 water. One is liquid, one is gas. Make sure we should use the standard Gibbs energy of formation for water gas. And the coefficient for water gas is 4. And then let's look at the reactants. Methanol is one of the reactants. The coefficient for methanol is 2. So we multiply by 2 moles. Another reactant is oxygen gas. When we look up the table, we cannot find the standard Gibbs energy of formation for oxygen gas. But recall that we learned that for the most stable element, the standard Gibbs energy of formation is 0. Mole will cancel. Mole will cancel. Mole will cancel. The unit we get for the standard Gibbs energy of reaction is kilojoules. If you punch all numbers into a calculator, the answer will be negative 1,370.62 kilojoules. This number is less than 0. So this reaction is spontaneous.